Hello, can you guys hear me? Okay, cool. Interesting. Um, some people did not show up. Okay. Anyway, maybe we can get started. The morning. Okay, let's see who else come to the morning. Anyhow, I will not worry about that. Okay, so so first is welcome to the intermediate algorithm for comparative programming, and some of you are with me on the summer, some of you are not. So today with basically the introduction. So there are some like administration work we need to go through. So then we will. Um, Number one is yeah, I think all of you already signed up for the Google Classroom, and I think all of you should also in the Discord, which is good. Okay, so and we have a two session, one in morning, one in afternoon. Basically, they should be the same. So it just have one more option in case if you have a schedule conflict. Okay. Yeah. Then so this one, yeah, I think most of you here are using Java and the C++, right? We don't have. I think there was a one in the morning doing Python, and he quit. So that's like yeah, because the Python is a really very different, versus Java and C++. An algorithm itself should be language neutral, but again, I will try to show the code in both Java and C++. So and also, um, yeah, and also the convert. Well, if you learn one of them, if you try to understand the other one, it should not really be a big problem because inside of the comparative programming domain, they share at least more than 80% of the similarity. So that's not the issue. Okay. So then, so number one, this class will kind of like targeting on the UCL civil. So make sure you have registered account here. Okay. Make sure you have a registered account here. So when you register, make sure you using your true name. And also, I think there's one more thing which is very important is the graduation year. Don't mess up your graduation year. Okay, so yeah, uh, and you should register as just students, not like me was as an observer. I mean, parents can only register as an observer. Okay, so because we will go through some of the past contests here. So and some of them will also be assigned as a homework. So if you don't have account, you cannot do that. Okay, that's number one. Second one is, I think most of you probably also know this website, right? So we are roughly gonna following the topic here, plus plus some other topic I pick. Um, so like essentially is I my plan is to cover majority of the civil topic plus some of the gold topic because some of the topic in gold is closely related to the civil, which is not. I don't really know why they are separate. For example, BFS. I mean, I don't know why DFS is civil, BFS is gold. That's make no sense. BFS and DFS they should talk together. So that's number one. Similarly, like the sliding window, right? Sliding window and the two pointer, that's really the same thing. So that's really, I mean, very closely related. And also about this disjoint set union, this is one of the actually um, tested quite often on the when you have this when you talking about the connected component inside of the graph. Okay, so to start, um, oh, And also, let me just. So, for folks who with me on the summer, then every week you will have some homework. Okay, every week you will have some homework. So just I will post the homework like weekly, and you will also find out the class video will be in here. For example, this one you will find the morning's classroom, the morning's video. Oh, what the heck is that? So the video is already here. Okay. Oh Jesus. Okay. Then uh, but unlike summer, because one of the feedback I got from summer is there was too much homework. I guess I was under the wrong impression, like folks has nothing to do in the summer, so so they can have more time. So I take account into that as a fact. So as a in the fall, what's going to happening is this. So essentially is um, so you will see the required homework, but I will discuss some of the homework in the class. So essentially is how many? One, two, three, four, five, six. Yeah. So there's 8 problems here, right? I will talk about the 4 problems today. So that basically means so essentially your homework will become with a three part. Okay. The first part is just redo the one we discussed in the class because uh, like you see how I show you how to do it doesn't mean you know how to do it. Even even I show you the solution, you just do a plain copy that you're still learning something. Okay, so basically is I want to make sure you at least you know how to do what we discussed in the class. Okay, then we will I target assign on average 3 problems every week. So I think that's kind of like the workload you can handle. So then this 3 problem will be roughly similar as what we talk about in the class. I mean, from difficulty level. Okay. Then if you have more time, if you want to do more, there's option. There's option one. Okay. Optional one will be slightly more difficult. Slightly more difficult. Then um, then I will actually I will go over very quickly on the previous week's homework. So this is unlike the summer because summer I didn't do that because the reason is one of them is due to time. The other one is summer is on the introduction level. So I think most probably is relatively straightforward. There are several one I haven't really yet. To speak of that, I haven't really posted a solution for that. I will try to find some time how I can do that. But for this one, I will post the solution for everyone. Okay, so this is if you so my suggestion would be if you don't have time to actually work on some of the problem, at least take a look at the problem, do some thinking, because for the musical problem, it's very important is you actually have to thinking through. You have to thinking through. Okay, once you're thinking through, then you kind of like already half done with the problem. Then then you just bring your thinking to the actual coding. I mean, at the civil level, probably this will still. I understand some of you may still not be that proficient, right? So, but that's actual reason. If you say, okay, I have an idea how to do this problem, but my code just doesn't really passing, all the tests, or my code just doesn't work in some cases. Show me your code, okay? Just send me your source code. I will take a look, okay? I will take a look. I will point out what is going on wrong here. And as a beginning, I shouldn't say the beginning because you guys are already passing the beginner stage, okay? You guys are already in the intermediate stage. So, but still, you will having cases like it just debugging sometimes potentially could take a lot of time. So in other cases, I would say just ask. Maybe there was just only 1 or 2 very, 1 or 2 places. It's like because this is something kind of different from the math. Math is you can really have to thinking through. Okay, CS there are things like it just you don't know or you know. once you know it, it's nothing. So it's not really like, so that's reason. So this is going to be true for everybody. Essentially, is I strongly encourage everybody asking questions. Okay, I strongly encourage everybody ask questions, and also ideally, I prefer to asking in the channel. The reason is, um, if you don't know something, the chances are there are some other people in the channel also don't know the same thing. Okay, so then you just ask, right? Then for me, I don't have to answer the same question over and over. That's number one. Second one is some folks in the channel, they may be able to help you as well, because because I cannot really respond to you immediately sometimes, because for example, if I was in a meeting, I was in some other thing, I kind of say I will respond to you within 24 hours. But if you need some like immediate help, sorry, someone, uh, just post it in the channel. Yeah, then okay. So I think that's pretty much of on the administration side. Any questions so far? Oh, one more thing is this. Sorry, what? Anyhow, one more thing is this. So I understand all of you are here because you really like coding, you really like the algorithm, right? So otherwise you won't be here, right? So, but at the same time, you should also understand, uh, this one is not supposed to be easy, okay? So you need to mentally prepare for the toughness. So that's like, and also since the school starts, right? So it's very important that you need to balance this with all the schoolwork, right? So um, I would say this is just for the like if at any point you feel like okay this is too much, it's maybe not good time for me. It is totally okay to just you know uh, quit. I mean, it sounds very strange, but really like because I understand like most of you are high school students, right? So GPA is still the number one thing. Okay, GPA is still the number one thing. This one is like compared with the schoolwork, it's still not. It's not. So it's totally okay to pick up in some later time. Okay, so that's the reason I don't want you to stress out to say, okay, oh yeah, there's too much stuff I cannot handle. Everybody will have that kind of moment. Okay, so that's the reason don't feel like, oh, I doing that because I'm too weak. No, it's not. Um, because I said the same thing in other things. Essentially, say what you guys currently did, what you guys currently trying to tackle is something is equivalent to like at least second year or maybe something is even in the third year college level course. So that's kind of the difficulty you're looking at. So what does that also mean is if you are looking at the same grade for the whole country, you are far ahead of majority of the people. Okay, you're far ahead of majority of the people. So if you feel stuck on some problem, it's not because of you're stupid. It's just because you're dealing with something really not that easy. Okay, that's it. Nothing nothing to be ashamed of, nothing to be embarrassed. You're just yeah. It's not easy. So but I personally feel it's very fun. I personally feel it's very fun. I will try my best to try to explain things, in a clear way. So that's reason. If you have any feedback, if you say, okay, hey, Sam, that part I did not really understand. Could you just explain again? Yeah, just do that. Okay, if you feel that one, you should do that. Okay, so that's okay. So today we're gonna start with something what we call the flood field. Okay, flood field. So let's just this. So what is flood field? So basically, in the UCO Civil, graph is one of the major topics that will be tested. We're probably going to spend at least 3, maybe 4 lecture on the graph. And I think in the introduction course, I actually talk a little bit about the graph traverse, right? So essentially, is you have a graph. How can you systematically visit the whole graph, right? So today we start with something that's a very special graph. Essentially, it's a board, okay? It's a board. So normally it's like a n by n board, right? So it's basically it's a 2D grid, right? So it's like n by n. So you have n, like m row, n column, right? Right. So it's something like this. Okay. So whenever you are attacking a problem, there's a couple of things you have to think about. Okay. This is true in general. First, number one is what kind of the state I need to representing, the things. Essentially, is what kind of data I need to represent in this problem, right? So depends on that. That would basically depend on what kind of data you try to representing. The reason I tend to call it a state because to represent, along the problem solving, the data can change, right? So that's like corresponding to some like a state change, right? Then depends on what kind of data you want to representing, you will choosing the proper data structure for that. So here's a simple question. If you want to representing the board like this, M row, N column, what kind of data structure you're going to choose? Anyone? You can either speak up or you can just type in the chat. This is not a, what do you guys think? Nobody? Seriously? Vector of vector or something. Yeah, that's basically right. So essentially, this is what we call the two-dimensional array, right? 2D array, right? Right. So then each cell could either be a, it depends on the cell, right? So for example, if a cell is an integer, then you can do something like this, right? Right? Or like in Java, you can do array list of array list. In C++, you can do vector of vector, right? So that's essentially is, right. Then once you're using that one, then how to access, any particular, cell. So suppose this is the ith row, j's, suppose I call this whole thing A, right? Then if you try to access this guy, you can easily access this one by aij, right? Aij, right? So that's, that's pretty relatively straightforward. Okay, so then the first you basically say, okay, I kind of like need to like iterate every cell on the board. Okay, then that also depends on the value on the cell value. I might need to do something. Okay, so to start off with the front view, let's look at one of the very classical example. Let me just do this one. Okay, so let's look at this particular problem. Don't look at the right hand side, just look at the left hand side. Okay, just look at the left hand side. Okay. So okay, so you have a board, right? The board is a character. So the character is either 1 or 0. Okay, so if you have a 0, so you use a 0 basically means that cell is a water. Okay, if the cell is 1, that means that cell is a land. Okay, then so each cell can either be a land or water, right? So that's pretty straightforward, right? So then we are trying to find out the number of the island, okay? So the number of island was defined as the land has to be connected. the connected in this particular case means they are either horizontally connected or vertically connected. Okay, let's look at the the second example. So in here, this is a 4 by 5, 4 by 5, right? 4 by 5. Then if you look at the upper left corner, so you have this kind of like a 2 by 2 grid. They are all one. So basically, this will form an island. Notice diagonal doesn't count as a connection. Okay, for example, this one they are diagonal, but the diagonal doesn't count as a connection. That's actually reason. You have the second one was surrounded by the water because it's top, bottom, left, right, they are all water, right? So so the second one is just a single one cell which serves as an island. Then the last one, the third one is on the bottom right corner, right? That's a 1 by 2, 1 by 2 island. Okay, so the question is, you are given a board. How do you find out how many islands are there, right? How do you find out how many islands are there? I think the question should be relatively, well defined, right? So let's just using the second example. Right, so this is okay. So I mean, I can go to any cell. The cell will tell me whether this is a land or water. That's easy, right? However, just imagine when I iterating, this one. Suppose I iterate this one row by row. When I first hit the first one, I know okay, that's an island, right? That's an island. That's kind of like you can think about that's the first piece of the island. So essentially, a couple of things. If you think about the data and the state, I probably need the global counter to record the number of the island, right? You will have a global counter, right? You have a global counter for that. Initially, it's 0. Then every time you see a new island, you should increment it by 1. That's easy. Then the question is, how do I know that's a new island, right? For example, when I go to here, okay, that's good. This is good. This is a new island. This is a new piece of island. Then when I go here, when I go to the next one, I need to know, okay, although this piece is a land, sorry, give me 1 minute. 什么事啊？不是这样。Okay. Sorry. Yeah, I thought it was calling me. No, it's not calling me. Okay. Okay. So when you go to the next one, although this is a land, but you have to know, okay, this is not a new land, right? This is this is a land, but this is not a new island. This island will belong to the first one, right? So this is where the flood field idea comes in. Essentially say, okay, if I reach the first piece of the land island, I can start from here to visit all the connected neighbors as long as they are land, right? I can mark them and say, okay, this is although this is a land, but it's not a new land. It's belong to whatever it's already kind of like so. In the graph traverse, we have this idea called visited, right? So essentially, on each cell. So okay, so now you think about the in terms of each cell. Each cell will have several different states. It could either be water or land, right? If it's land, it could also be the first land, basically kind of like the new land, or it's a land but belong to another already visited island. Okay, so you see the state was that's like kind of like so basically the idea is okay, I reach my first piece of island. Then I do my flood field. The flood field essentially is just start from this piece. I visit all my neighbors. To check whether they are land. If they are land, I mark them. Okay, this belongs to me. This belongs to me. So until I reach the water, right? Then I will done because presumably the area for land is finite, so it's not infinite, right? So it's like eventually it's going to stop. Eventually it's reached all the border, it's going to stop, right? So then essentially, for example, in this particular case, you can think about it, okay, I'm reaching here, okay, this is good. So now I mark this guy, mark this guy, mark this guy, right? Then after you visit this one, all these 4 cells will be marked as visited island. Now you continue. We say, okay, so this is not, this is water, 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 until I'm reaching here. Oh, what the heck is this? Is a new island. At this time, I'm also going to do another flood field essentially to see, but in this case, because all the 4 neighbors, they are all water. So this is only like a single cell island, right? So now you see the idea, right? Now you see the idea. After you visit everything, then every time you reach to a new island, you increment to the global counter. Then after you visit the whole board, you will have the record of the total number of the island. Okay, so that's basically is the idea how you wanna do that, right? Then in terms of the neighbor visiting, right? I'm at here, so my neighbor will just gonna be this 4, right? So if this guy is IJ, then this would be, I minus 1J, because this is the previous row, the same column, right? This is the next, right? So this will be the same row, but it's like, right? So, right. So this is like you have 4 neighbors, right? This is how you're actually gonna visit, right? Okay. So let's go to see in the code how we can implement that. Okay, so this is the Java code, right? So if you look at, let's first look at this thing, number of the island. Okay, so it's getting a character of grid, right? So line 32 to 34 always check the boundary condition. Essentially say, okay, if the board is empty, then you really have nothing new to do, right? You have nothing new to do. So then after that, you just get the dimension about the board. Essentially is the number of row and the number of the column, right? Then I have this counter in here, the counter is initially set at 0. Okay. Then I have this double for loop to iterating this 2D board, right? So if I have reached the first piece of the island on first piece of the land on the island, I will increment, the number of islands. Then I will do my, in this case, the DFS essentially is doing the flood field. Okay, so the key is the flood field. Let's see what do we do in the flood field. Okay, in the flood field, again, we got the dimension. We got a dimension. The first step is always check whether the current state is valid. So this means 2 things, right? One is, this we are just gonna make sure I'm stay in the current board, because essentially this is a boundary condition checking, essentially to make sure my index is within the board, right? Because I'm going like a left, right, up, down. If I'm keeping doing that, at some point I will go out of the board, right? So which means either it's row reach to, if you reach to the left end, the row gonna become less than 0. If you reach to the top, then your column gonna become less than 0. Similarly, the other 2 ends, right? So then what does this one mean? This basically means, okay, you are stay at the current board, and also you are, because the current cell is supposed to be a land, right? If it's not a land, then you can just return right away because there's nothing to do here. Okay, maybe it's a water, or maybe it's some land that already get visited. Okay, Then after that, I immediately mark this land as something. I mean, for this particular problem, you can mark this land to be anything, as long as it's not equal to 1. Right? Previously is equal to 1. Now you can change you can change it to 0, or you can change it to anything non-1, which is fine, right? Then basically this is kind of like also what we call is mark current cell as visited. Mark the current cell as visited. Now you will do the flood fill. So the flood fill, first you can look at the commented part, right? Commented part will doing the job. Essentially say, I'm going up, I'm going down, I'm going left, I'm going right? So that's just fine. So another way to rewrite this one is you're using this what we call the directional like index. Directional index essentially is storing the diff if you're going up, down, left, or right. For example, if you row -1 essentially is you're going up, right? Row +1 you're going down, right? So column -1 you're going left, column +1 you're going right? So then I can just run a for loop. I do a DFS. Then basically every time is the current one plus the diff. Current one plus diff will give me the next position I can go. Okay, so that's pretty straightforward, right? Pretty straightforward. Okay, so let's also looking at the C++ version. So what? I don't have C++ version. Okay, I think I thought I do. Okay, anyway. Ding. Okay, so let's look at the C++ version. C++ version will be similar. It's almost identical. The only thing different is previously unnecessary space. What do you mean by unnecessary space? Which part using the unnecessary space? You mean the memory in terms of the memory? This static array. Oh yeah. Well, yeah. But that's. I mean, the answer is yes and no, right? So yes, it's using some extra memory. That's for sure. The static array, but in this particular case, you can see this array is very small, right? This array is very small. This is a fixed array. It's like it only contains 4. It only contains 4, so it's not really a huge deal. If you actually calculated the actual size, it's gonna be very small. So I will leave that one as you. So definitely, yeah, that's a good thinking though. That's a good thinking though. So when you write the program, you should considering both time and the space. If you like and also later we will talk about how you can trade off between time and space, right? So if your algorithm did not run fast enough, then in the use code you will get a timeout, right? If you're using too much memory, then you will get out of memory, So they do have a restriction on that, and also the higher level you go, they're gonna they have a more restricted condition, and essentially is there are certain technique to handle that. For example, space you can do some kind of compression, but it's not. I mean, we will see if we will actually have a chance to talk about that, but I don't think that's a concern here because really the one you added is actual, 2 array each with 4 extra element, which is almost is like I won't say nothing, but it's really very small, very 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 small. So that should not be affecting us in this particular case. Okay, so yeah, but that's a good thinking though. So okay, so back to here. So I will try to show the solution in both C++ and Java, and also this is also I think a good learning for both sides, right? So you can see, if you Java you look at this code, you can still understand it, right? It's not because I think 80% of code is the same. The only difference is really this part, which is instead of using array of array, using vector of vector, then this emphasize essentially base means passing by the reference. right? You don't want to parsing by the copy because copy will that's kind of thing which is special for C++. In Java, besides the primitive type, everything else object they always parsing by reference. So that's actual reason in Java it kind of like you're always parsing by reference unless it's a primitive type. Okay, so then the other thing, one minor difference is in array case you have this length, like that's a attribute, right? So in here you just calling size, which is I mean you can kind of like guess what this one's supposed to return, right? For all the other one, they're almost the same, right? So that is for this question. So that is for this one. Okay. So okay. I think this one is relatively straightforward. So any question about this one? Any question about this one? So one thing I do want to mention in here is, so in most of this problem for the 2D board kind of thing, your neighbor is like you have four neighbor, you basically horizontally, vertically. But what happens if you do this? Well, what happens if the diagonal is also work? So actually, what happens if you allow diagonal? I mean, you actually found out that's really not much change, right? Because if this guy is ij, this is just going to be I minus 1, j minus 1. This would be I plus 1, j minus 1. This will be I minus 1, j plus 1. This will be I plus 1, j plus 1, right? So instead of doing 4 like recursive call on the neighbor, you can do 8. And also you can also put the diff into your directional array, which is which will be very like easy for to handle. So okay. Okay, so yeah. Okay. This question is very, very important because this is essentially is the just try to understand this this part. Then many other problems are based upon on this one. You can see a lot of variation based upon this one. Okay, so okay, I'm gonna and during this lecture we can see how we can start off with this one to handling basically adding some actual variation on top of that. So let's see the next one. So let me see this one. So okay, so this is okay. So this is just look at the left hand side. Don't look at the right hand side. Okay. So can I just is there a way I can? No, I can't really. Oh yeah, I can just do this. Okay, cool. Okay, so let's look at this particular problem. This particular problem almost had a similar setting with the previous problem. Okay, let's think about this one. Okay, so it's essentially basically this one. So okay, you have all the island. You have the island, right? In this case, it does not want you to calculate the number of the island. Instead, they want you to output the island with the maximum area. Okay, so you can think about the previous routine. You can probably still using the previous routine, right? But you can based upon that adding one extra logic, just adding one extra logic. Essentially, is what that was missing is so. Remember when we reach the first island, we reach the first land of the island, we're gonna visit every land on that island, right? So we can using that one to calculate the area for that given island, right? So then after we're done, then we will know the area for that island. Then we can have something like a global, counter essentially say to store the maximum area you've seen so far, right? Then if a new island, you calculate the area of that island, then you compare with that one, then then you can do the proper update, right? You can do the proper update. So that's essentially is this that's essentially is this problem, right? So okay, so let's look at the code. Okay, so you will see it's actually sheer majority of the code, right? So okay, instead of that one, so okay, so let's look at the from 33 to 57 first. So again, check the base condition. If the board is empty, you have nothing to do, right? Then get the dimension about the board. Now I'm keeping this thing called the maximum area. Essentially, say okay, initially it's just going to be 0. Then if I reach the first land of the island, okay, that's in this case this one equal to 1, right? So then I have a global counter somewhere in here. So this is a global one. I mean, one of the things for USICO is this is a really bad software engineering practice, but this is a very good inside of the competitive programming. Essentially, is if you have some variable, it will be used in multiple functions. Instead of passing the variable, you can just define that one as a global variable. Okay, so that way you don't have to passing this variable along. Especially for the complicated data structure, you can just define there. I mean, we will see some example, in the actual USICO, problem. Okay, so in here, this is basically this is a counter to calculate the area of the island I'm currently visiting, right? So now I meet a new island. So I will reset this counter to be 0. Then I do my flood fill. Essentially doing the DFS. Doing the DFS, this one will, after DFS is done, it will calculate the area for this current island properly. Then after that, then I will comparing the value with the current max, right? If this is just a very short and easy way to say, okay, if you are larger than my current max, I will get it, right? So it's because it's max of the max is going to return them, the bigger value. Okay, let's think about it in this function. Still, the first step, get the dimension, right? Then check whether the current state is valid, right? Check current state is valid. Current state will not be valid under 2 conditions. Either it's outside of the board, right? Outside of the board. Second one is it's another land. It's another land, right? It's another land, right? It's another land. So then, after this is done, then I can just say, okay, I basically use this another way to mark this land was visited. So in this particular case, because everything is like integer, right? So 0 is water, 1 is land. I mark this one as a 2, means it's a land, but it's not a new land. Okay, it's a land that is kind of like old land, right? So then after mark that one, I'm incrementing the current counter to calculate the current area, right? So then the rest is the same. I'm flood fill my neighbor, right? So after this one, then then the maximum area will keep the maximum area for all the island. Okay. So this is also pretty straightforward, right? This is also pretty straightforward. Okay. So here is a question. This one shows how to calculate the area. What happens if I ask you to calculate the parameter of an island? What can you do? What can you do? What can you do? If I want to ask you to calculate the parameter, anyone has any idea? Okay, let's see. We have one. Very good, very good, very good. Okay, so this, I mean, basically is Chris's idea essentially is considering the number of zero adjacent with the one, with the current length, right? So yeah, that's exactly what we're gonna do, right? So uh, so the only one thing you'll need to basically consider is what happens if it's on the boundary, right? So but you kind of like already getting that, right? Yeah, I think Frank has the same idea, which is pretty awesome. So when you don't know how to do this one, just give yourself some example. It's gonna be like, for example, okay, so this is the one. If this one is surrounded by the water, then okay, that's like a 4, right? So this is gonna have a 4, right? If this one is like this, if this one is surrounded by the land, this is like a 0, right? If this one is something like this, maybe one side is water, then this is 1, right? So that's actually the reason. So this is idea would be relatively straightforward. Essentially, is okay. When I go to this land, I increment my, I just check for my 4 neighbor. More precisely, essentially is the number of the non-land, because it could either be water or it could be, out of the boundary, right? So that's like so. But if you have a land, you the number of land you're gonna minus that. So that's basically is the yeah. But I think it is good. I think you guys all get the how to do that. So let's see one of the problem in here. What? Oh, let's see. Why I'm looking at this one? Okay, so let's look at this particular problem. This is exactly the same as what we just discussed. Okay, what? I did not log in. Yeah, I think I'm pretty sure I logged in, right? Okay, so let me do this one. Okay, so let's look at this particular problem. So this is 2019 January civil. Okay, so Farmer John is creating the ice cream business. Okay, then they had Farmer John has an N by N grid, N by N grid, N by N grid. So then the grid is only have 2 character, either the punky or the dollar sign. The dollar sign representing the empty space, the punky representing 1 by 1 square of ice cream, right? So then they try to find out. Essentially, this is essentially say they try to find out the area and the prime of largest area, right? Largest area. If multiple area ties for the larger area, he also want to know the smallest perimeter. Okay, so essentially is they want to find out the largest area. If there's only one of them, you also want to output the perimeter. Essentially, for every island, you need to calculate the area and the perimeter. Okay, so that's exactly we just did. So just exactly what we did in this particular case. So essentially is okay, let me see this one. So just like what we talked about the previous way, right? So find the island, then also calculate the area and the perimeter, then then you have some kind of like a global counter to store the maximum area and the smallest perimeter. Then every time when you calculate the one for one island, you do some comparison with that thing. Then you can just updating that value accordingly, right? So that's the easy part. Okay, so I think this question is relatively, self-explained, right? So let's see, actually on the code, how we actually gonna do this one. So let me see. So, okay, so for this one, I didn't really got a chance. I didn't got the time to finish a C++ version. So let's see the Java version. I will post the C++ one, soon. So yeah. So if you look at this guy, okay. So, I mean, if you see the problem, it's also very similar as what we did in case, right? So basically, is this, right? So okay, see the man. Okay. Oh, couple of things I need to mention essentially is about the file, about the reading the file and the file I/O kind of thing. So, oh no, in here, look at the input, right? The input first is for Java. This is just well, I think it's from before last year, because USICO used to handle everything from file in and file out. Right now, it's changed to the standard, standard console. Okay, so for the file one, I have an example in here. Essentially, is the file name has to be this problem's name. This problem's name. Oh yeah, they do have something in here, something like perimeter, right? So this is the this is the input file. So you're gonna basically do the input file. Then the input is always in whatever this one dot in, right? You write to whatever this one dot out, right? So I just had this kind of like a standard thing. Essentially say, okay, I have a file reader, then do the buffer reader. Then after this one, I hook up this input file with my buffer reader. Then after that, every time I do f.read line, it's going to read the next line in that file. Okay. So for example, first time I call f.read line, it's going to read this 6. It's going to read this 6 because in this case, it only had one integer. So I can just call integer.parser to convert that one to be an integer. Then after that, every time I read a line, I'm going to read a string. By default, it's going to read a string. By default, it's going to read a string. Okay. Then in the string, I can just iterate the string to assign the character, one by one to this board. Because so this is also the one I was talking about. Essentially, is for this variable, because it's going to be used in multiple methods. So I just initialize outside as a static variable. So I don't have to worry about passing the variable. Okay. So essentially, because both methods can have access to this variable, right? So then I don't have to worry about that. But again, it's a very bad software engineering practice. But anyhow, that's for So now essentially, so this part handling the input, right? I'm reading the file. I know how many, the size, the dimension for the board. Then I initialize the board. Then I'm reading the board. So after this one, board IJ will contain the required board, right? Then I'm initialize this maximum area as 0 and the minimum parameter as that's a kind of like standard one, right? So then I'm iterating. I'm using this double for loop to iterating the board, right? If what I reach here is the first piece of the ice cream, I need to calculate the area and the parameter for the current ice cream, right? So that's really I'm kind of like reset this value. I'm doing my float field. Basically, after the float field, you can think about area and the perimeter will correctly calculate the area and the perimeter for the current ice cream. Okay. Then I do the simple update. Essentially, okay, if this area is larger, then I want the larger one, right? So I will update in my maximum area and the perimeter. If they are the same, then I need to get the smaller perimeter. I need to get a smaller perimeter, right? So that's basically this is handling, to keep track of this. Then after that one, then I'm just output the results. Okay, output the results then write to the one. So still the key here is in here. here using this flood field. Then you see the flood field it's also the same, right? The flood field is also the same. So again, check the invalid state at the first step, right? Check the invalid state. So basically, if it's not out of the bound, and the current one is ice cream, because if it's not equal to punky, then that's not ice cream. I should just return right away, right? So now this is ice cream. I have not, so kind of like I can set this one to be anything as long as it's not equal to punky. Okay? No, sorry, no. For this particular problem, I can set this one to. I cannot set this one to be dot. If I set this one to be dot, it will affecting how I calculated the perimeter. But I can set this one to be anything as long as it's not a punky, not a dot. Okay? Because dot has a special, meaning in this particular case. And also, I'm incrementing my area, right? Because it's a new area, it's a new piece of area. So this is the piece I'm actually doing my perimeter calculation. Essentially, is left has a, so this basically handle two cases. If left is already reached the boundary, right? If left already reached to the boundary, oh sorry, I is the row, right? If I is the row, then that's the top, right? I is row, then that's the top. Do I already reach the top, or my upper is non-ice cream, right? Essentially, that's kind of like both cases with we are incremental my perimeter by 1. This is true for the other three dimension, for the other three direction. Okay, so then I can do this. Okay, so you may wonder, hey, you did not do that like a dx thing, right? You did not do that dx thing, right? You did not do that like for loop, like directional thing. Yeah, there is one implementation detail in here I need to talk about. Okay, so but again, this is a pretty straightforward, relatively straightforward the problem, right? So it's like so that's yeah. So I can do the directional one. If I do that, I can pass in the first 10 case. I cannot pass in the last one. There is a one really like a little bit, let me talk about this one. Let me stop sharing this one. Okay. This is something what we call the tail recursion optimization. So again, from software engineering perspective, that for loop with the director X is much better than if you do for copy. Essentially, the whole idea is if you see some kind of like repeated code from software engineering wise, it's just bad. It's just very bad. If you see anything so you have to think about how you can but for this particular problem there is an issue. So I think everybody know what is a recursion, right? Everybody know what is a recursion, right? So recursion. So I have a function. Say I have a function foo. In this particular case, it's return void, right? Oh yeah, that's just my function DFS, right? So if you calling DFS in the middle of something, DFS something, then what's going to happen is, suppose I call this one n, I call this one n minus 1. Remember, this is if the recursion is in the middle of the in the middle of the body. Okay, then what's going to happen is every recursion gonna creating. So this is your call stack. Essentially, what does this one means is you have a DFS n. You're calling the right. Actually, whether it's n or n minus 1 doesn't really matter as long as you're calling yourself. If it's in the middle, for DFSN, it's going to stop at here. Why? It cannot execute the later code without waiting. It's kind of like you need to wait for the result of this guy after that right. And also there's another possibility. Essentially, say if I probably put that one. So essentially, is this one has to right. So it needs to wait for this guy to return. Okay, so this is one case, right? The other case is like this. The other case is if your recursion does return something, say suppose you have say integer DFS, something, then you do, then you have some variables. Okay, integer results is equal to DFS something. Okay, so this is n minus one. Again, this is same thing. The DFSN has to wait for this one. Okay. Right. So so it needs to return. This is kind of like a normal recursion, right? But there's one particular case. This is not necessary. That's what we call the tail recursion. Essentially, this one has to be void, and the recursion must happen at the last line. Essentially, you call DFS. Basically, is it kind of like this DFSN only dispatch this call at the last step, and also it doesn't return. It doesn't need to, because this guy return nothing. It doesn't really need this guy to return. You essentially say it's just like think about this. You assign a job to another people. If you need to wait for that guy to report you back, then you have to wait. Or in this case, essentially say, okay, you just can say, okay, I assigned this job, then I'm done. Really, this DFSN is already done because it doesn't really need to wait for this result. So your code will compile to the machine code. Then the compiler will be very smartly to say, okay, this is kind of like a language space. Essentially, is when they see this code, they say, okay, I can optimize this one. So in the call stack, what's going to happen is you will not have this case of DFSN is waiting for the DFS n minus one, because it's just no need for the DFSN to stay here. DFSN after this guy triggered the call, it can gone. Okay, so really like I can. Okay. So I say, okay, I can optimize this one. Say, okay, I can just right, because even this guy return nothing, and nobody is waiting for this guy to return. Okay, so this is what we call the tail recursion optimization. It's a little bit too detailed, I feel, but from semantic wise, those two pieces of code should be equivalent. Okay, semantic wise, those two code is equivalent. But in practice, if you do that, you see that one does not work. You sometimes just change to this one, then it could work. And so you could have something like if you see something like timeout, or you see something like stack overflow. I do see this one in another use case civil problem, the stack overflow, because in this particular case, because all the core will be stacked together, right? So, but the problem is this call stack is not infinity. It has like a size. I think that also depends on your memory. Like I think in my desktop I tried is like roughly like 3,000 or 4,000 some 3,000 or 4,000 something. But your recursion may run into more than this many level. If without the tail recursion optimization, with the tail recursion optimization, your call stack is only have one. You don't, because this one doesn't work. Because you can imagine if you don't with this one, then if you do like a DFS say 10,000, then it's gonna then the next one is like 900, 10,000. Then you do then every time you decrement it by one. Now you can imagine your call stack is gonna easily boom, it's gonna fill up with all that one, right? So basically this is the one of the practical trick. You can try. I would say try that one first. If the loop with the directional index doesn't work, it can always split into 4 separate calls. Okay, semantic wise they are really the same. Semantic wise this one should have no difference. Okay, so that's just one. So I would say along the line you will see a lot of the, I don't know what to call it, kind of like the trick or whatever, the tips or thing like this. Okay, so okay, so this is for this one. Any questions so far? Oh, this is good. Okay, so let's see. Let's see another question. This question will be slightly more difficult. By the way, yeah. Oh, I said right. So yeah, I didn't got a chance to get a C++ version. I would do the other one next week. So yeah. So sorry about that. Yeah. Okay, let's look at this particular question. Okay. So this is also a very interesting question. Okay, so again, Farmer John built a bond. It's an n by n grid. Okay, see, it's another 2D board, right? 2D board, right? So the number is from 1 to nn. Okay, so there's another thing essentially is most of USQL one they like to do 1 to nn. So, but we know the array index is like 0, 0 to So when you read the input, you can just do a shifting by 1. So then then that's not an issue anymore. So then what's going to happening is each cell is a room. Okay, each cell is a room. Initially, the basic at the room 1, 1. Okay, then in each room, they may have some switch to turn on the lights on other room. Okay, then anytime you can only go to your neighbor room if the room is the light is on. Okay, so then they're asking you about how many rooms Bessie can light the light. I first made a very stupid mistake on this particular problem. I did not read what the question is asking. I thought that the question was asking how many room Bessie can visit. It's also very funny. It's like in first a couple of test cases, I think it's the same. So that's reason I was like I was having trouble on several like cases until I realized, oh, I read the wrong problem. So yeah, so I think that's a lesson for everybody. It's make sure you read the correct problem. Okay, especially if you read it wrong, then it doesn't matter how beautiful the code you write. It's just gonna be wrong. Okay, then that's the one thing I learned. Then for this particular problem, there's a couple of things, right? Still go back to think about the data and the state about the thing. Again, you have a 2D board, right? Each cell is a room. Then in here, each room will have several different states. One is whether you have visited this room or not, right? You may be visited or you did not visit. In this particular problem, you also have another state, which is whether the room has a lights on or off, right? So, that's kind of, so that's kind of thing you have to think about, when you think about, when you like tackle this problem. For example, how you can represent, essentially how you're representing, say, the state for the room, right? You need like, for each room you have at least it's whether the light is on or off, whether you visited or not, right? So you need at least this to represent in the room. That's number one. The second one is the switch is in the room. In each room, they may have multiple switch. The question is, how do I representing the switch? So one way is I'm doing a flat list. Right? Flat list. So the list will basically say, okay, for example, in this particular problem, I have a 6 switch, but you realize, okay, room 1-1 contain 2 switch, one open 1-2, the other one open 1-3, right? So, okay, you can using a flat list to store all the switch. However, if you do that, then thinking about what are the one of the operations you can do very frequently. When you go to a room, what do you need to do? When you go to a room, one of the things you need to do is you need to turn on the switch that is located in this room, right? Which means it's gotta be better if you can. Essentially, the operation what you want is given you the position for the room. Give me the list of all the switch that in this room, right? That's the reason if you have a flat list, every time you have to go through this list, search again, right? So that could be very time consuming. That's also one of the problems, I think some people got a timeout, okay? Because later, your room, you could have a lot of switch because you see here, N is actually not very large. N is like 100 to 100. Oh, so this is another thing. Like I think this is another thing. I think I want to anchor what Frank just asked, right? So in USQL problem, you don't need to worry about the memory, but USQL they will give you the range about the number. Then you can using that one to roughly. If you try to using some certain data structure, you can do a rough estimate to see whether this will fit into the memory. And also, I don't remember exactly, but I think at the USQL somewhere they're actually talking about. I don't remember. It's like that's in the. Yeah, okay. I'm not going to find it here, but I remember there are something like they talk about how big the memory. I think it's 2 megabyte or 4 megabyte, something like that. So basically, is based on that you can kind of like calculate, whether you will ever running into out of memory problem. Okay, so then in this particular case, you can also see N is not very large. N is like at the most 100 by 100, but M could be like 20,000, right? So that's actually the reason. If you have like 100 by 100, think about essentially you could have like 10,000 room. Then for each room, if you're gonna go through the list of this one, that's gonna be very slow, right? That's gonna be slow. That's reason you should not probably store all the switch in a flat list is probably not such a good idea, right? So that's the reason. So in this particular case, what we can store this one is you can store this one as two-dimensional array, but each element in the array is a list. Okay, is a list. So I will show you how to do it. So once you get that, then to fetch the switches for that particular room, it's going to be super easy. You're just indexing the room location, it will give you the list. Okay, so that's also one of the other ones. Okay, then so this is in terms of how we can represent the data, right? Then let's try to like mentally working through how this thing gonna work. Okay, so okay, I start with room 1-1. I start with room 1-1. Then I will turn on the switch. So when I turn on the switch, this may turn on, the lights for some room, right? Because I'm trying to calculate the number of the room I can turn the lights on. So when I turn on the lights, I can check whether this room previously was on or off. If this one previously is off, then now I turn on the lights, which means I got one more room which was light on, right? So which means if I have some global counter I can increment. If I have a global counter on how many room I can light on, this is the time I should increment on that, right? So that's, relatively straightforward. There is one very tricky thing for this particular problem. Okay, so you light on some room, right? So if the room happen to be the neighbor you're currently in, that's awesome. Then which means you can visit that room. So in terms of the flood field, this one adding one extra condition. Essentially, I'm still gonna visiting all my 4 neighbors, but I can only go there if the light is on. If the light is off, I cannot go there, even if it's my neighbor. Okay, so in terms of flood field, it's also easy. I can just do one. I just add one more condition. Say, okay, I'm going up, going down, going left, going right. If it's no light, then then sorry, I'm not. I just can't do anything, right? The problem happening in here when I turn on the lights for a room. What happens if this room is not connecting to my current room? Right? That's very possible. I'm at room 1-1. I'm turn on the lights maybe in 2-3, right? Now what I'm gonna do? So okay, that's a tricky question, right? That's a tricky question. So okay, so this is actually this is actually one of the issue, which is this is one of the issue that's like lots of people missing from this particular problem. To give a concrete example, let's thinking about this one. Okay. Right. Initially, I'm at 1-1. Suppose this is right. Suppose 1-1 has the lights to turn on 1-2 and the 2-1. Right. This is good, right? So then, suppose 2-1 has the lights turn on 1-3. Okay. So here's the issue. Okay. So initially, I'm going here. And initially, the lights will be on, okay? Now I'm turning on these 2 lights, right? Then, suppose the next one I'm visiting is 1-2. Next one I'm visiting is 1-2, okay? 1-2 doesn't have any switch. So, if I'm trying to visit in the neighbor, 1-1 I'm already visited, right? 1-3 currently is dark, I cannot visit. 2-2 is dark, I cannot visit. So, I'm gonna go to 2-1. When I go to 2-1, I'm gonna light this guy. This is a very interesting one. So think about this one. Okay. Now you see 1-3 is clearly here. You're currently at here. Okay. 1-3 is not connecting to my current location, but from this one you can clearly see I can visit 1-3. Why? Because 1-3 is the neighbor of 1-2, and the 1-2 is something I'm already visited, right? So that gives me an idea essentially say, okay, when I lights on a room, I need to check, because essentially it was one basic idea essentially is all the room you already visited, they are connected, right? All the room, look at this purple one, all the room you visited, they are connected. You can kind of think about, okay, you can be in any room at any time, as long as this room is something you already visited. Which means if I'm lights on a room which is a neighbor to any room that I already visited, I should be able to visit that room, right? So this kind of like changed how you flood field, but that doesn't matter, right? Because in terms of code, I'm just do an actual recursive code. It's really nothing matter. Okay, so this is the key. So as a contrary, if this guy was turned on the lights in here, then I cannot do much, right? If suppose if 2-1 is lights on 3-3, then I cannot do much because this one, at least what does that mean is I cannot visit right now. I cannot visit right now. Maybe after future I might be able to extend to there, but at least for now I cannot visit. Okay, so that's kind of like very important for this particular problem. So so basically is for this particular problem, you still do the flux field, you're adding a couple of extra stuff. If let's recap, number one is how you store the switch. I do see some people, they store the switch initially just store as a flat list. Then they got a timeout in some of the test cases. Okay, so but that was testing on like the time complexity and the efficiencies, right? Then from the logical wise, the key here is if I'm turn on the lights for some remote room, if this room I need to check whether this room is connecting with any room I'm already visited. If they do, which means I can visit that room right now. If I can visit that room right now, I might just visit it, right? Because every time I go to a new room, I can potentially turn on more lights, right? So that's essentially the idea. Okay, given this one, then we can write our code. Okay. So okay. So you see here, okay, so here's the thing, right? So okay, I'm skipping the input. See, number one, I'm using two board to representing, the first one representing whether the cell is on or off, right? The second one to representing whether this room has been visited or not. So this is what I'm talking about. Essentially, is you have a two-dimensional array, but each element is a list. Each element is a list. Okay. Then in Java, because the room has a row and a column number, so I'm just writing a really dummy class, considering both row and a column. Okay. Then with the constructor, that's all I need. Right. Then in C++, this will be easy because C++ has a pair, so you can just do a pair. So C++ you can probably do something similar. Okay. But the C++, I don't think C++ has the dynamic. Actually, I need to double check because okay, so I will go back to here once we finish this one. So here we still have the directional index, right? Then I have two variables. Result will be the number of the lights I can turn on. N is basically the dimension about the board, right? So I'm reading the input. So in here, looking at this guy. Oh, not this one. Sorry, come on. So this input essentially is we do like a buffer reader f buffer reader n dot read line. It will give you a string of this one, right? Then in here, this is a one line contain two integers. So you will need to do basically the way you can do this one is you using this string to initialize something called a string tokenizer. String tokenizer will automatically break your line into the token. The way you do this one, you just call next token, next token, next token. For example, in this one, you just call twice, the next token, right? So the first one will give you n, which is the size of the board. Second one give you n, which is the number of the switch you will have, right? Then after that, you will get, the line will contain 4 integers. The first two will donating the location for where where the switch will be located. The last two integer will denote which room this switch will be turned the lights on. Kind of like think about the source and the target, right? That's what I call source and target, right? So again, I'm reading this line. I'm reading the line using this string to initialize the string tokenizer. Then I'm reading this for integer by calling st.next token. I do the -1 shift to handling the case from 1 to n to 0 to n-1. In this case, it really doesn't matter, right? So then Sx and Sy essentially is say where the switch was located, right? So then I will just add in this one. So now if I try to pulling out all the switch from any particular room, I can just easily call switch X and Y. Then it will give me the room, all the switch in the room X, Y. Okay. So then the first room, initially I go from the room 0, 0, that's kind of 1, 1, 1. So the light is on. Because the light is on, you know, the number of the lights, because without this number of the room can be lighted, right? So we're gonna start with this one as 1. Now I'm doing my flood field. Now I'm doing my flood field. Okay. So let's look at the flood field. Flood field again. I'm having this separate method called isValidIndex. isValidIndex essentially just checking whether it's out of the boundary, right? It's out of the boundary, right? So if it's not invalidIndex, if it's also already visited, or if it's the light is not on, then I should return because that's an invalid state. That's an invalid state, right? So I should return right away. Then the immediate next step is I'm marking the current room is visited because I'm currently at this room, right? Then when I'm in this room, what I do? First thing I do is I'm turn on all the switches in the room, right? So to get all the switch, you just do this, right? So this is gonna be that's reason, you know, this is way better than a flat list, right? So this will give you a list. Then, you know, for each room, so this part essentially say, okay, I'm about to turn on the lights for this particular room. I need to check whether previously this is on, right? If previously this is on, then you're not really lighting a new room, right? So, but if previously it's not on, then I light it on. I light it on, and also I know I lighted a new room, right? So I'm result plus plus, right? So this is the one I was talking about. If actually interesting, I'm checking whether this room is visited or not. Supposedly, if this room light is not on, it's not supposed to be visited, right? But anyway, I think there's no harm to check that. Oh yeah. Oh yeah. No, because I'm only lighting that room. Maybe that room with the light is already on. So yeah, so I do need to check this. So if this room has not been visited, and I have a method called can I visit this room? What this guy do? Can visit basically say, okay, can visit this room, essentially say, if one of my neighbor is visited, right? If one of my neighbor is visited, so this basically means I'm calculating I'm using directional index to find out all my 4 neighbors, the index of all four neighbors. Then I check whether it's a valid index, and also whether this is already visited. If that's the case, basically means I'm a newly lighted room, and one of my neighbor is some room I'm already visited, so I can visit this room right away. When I say visit this room right away, essentially I'm just do a flood field, right? Then I will do the normal. I will do the Euro thing by checking the neighbor. I will do the normal thing by checking the neighbor, right? Just do the DFS of this. Okay, so overall structure is still very similar, right? I would say only this part is actual, only particular to this particular problem. If you see the rest, it's essentially is still the same as, you know, the standard flood field kind of the standard float field kind of like approach. Okay. Yeah. I don't recall whether how the C+ is dealing with the dynamic erasing, but in the worst case, if you cannot initialize that one as a dynamic array, I guess you can always do the vector of vector. So I think that's so that's really not the issue. So yeah, and also if this parameter is not big, because kind of like n and m is only this large, right? So you can just initialize a fixed size of the array using the maximum number. So in that case, you need to do the calculation to see whether it's actually gonna blow up the memory. Okay, but I think for many like a code force problem, that's basically lots of that seems to be a pretty common practice, folks do for so okay, I think that's what I want to talk about for today. So I'm gonna stop here. Do you guys have any questions so far? This is all good. Let me just go back to the So the homework one will contain, I think the fourth problem is what we today talk about. Then the other four, I think three of them should be relatively straightforward. There's one of them which is slightly tricky. I think that's this one, real spicy. This one is a little bit tricky. Then yeah, but this still this is still the standard. You will need to using float field as one of the routine to to keep running some of the stuff. Then yeah, but I think it's doable. It's not totally undurable. So that's like this. And again, I'm thinking about I might give out some hints, during the in the middle of the week. So if you really stuck, you can't make any progress, just let me know. I will give out some of the hints. Okay, because and also for the optional problem, there are certain tricky parts. So, but I will briefly discuss the problem next time. Okay. So, any question? Or you guys all good? Okay. As always, if you have any question, feel free to reach out to me. Then Discord, email, both are fine. Then yeah. Other than that, I will say I will see you guys next week. Okay. Bye.
Thank you. Bye.
Thank you.